Hello everyone. In this video, we will see how to program a line follower. We will have two variations of line follower, one with a thin line and one with a thick line. Now let's first see how the line follower will look like. So this one is the thin line follower and this is a thick line follower. This is our vehicle and we have two IR sensors attached. Why do we need two IR sensors? Because we need to program 4 actions. The vehicle has to go forward, the vehicle should be able to turn right, vehicle should be able to turn left, and vehicle should stop. So there are 4 actions and that means we need 2 sensors. Why? Because the number of actions and number of sensors, they have a relation. It is 2 raised to n equal to number of actions, where n is the number of sensors. Because we are using digital sensors, we use base 2. So 2 raised to n, where n is the number of sensors, that will give you the total number of actions you can program using those n sensors. So in this case, we need 2 sensors because we want 4 actions. 2 raised to 2 is 4. So we need 2 sensors. Now in the thin line variant, the black line is in between these 2 sensors. And so that means we are traveling correct if our both sensors are reading the white value. Let's assume that because of some reason our robot turns, and now if you see, it is the left sensor which is on the black line, and that indicates that I need to turn back to the left, so that the left sensor goes into white area again and we are on the path again. So if my left sensor is showing black while the right sensor is showing white, I need to turn to left to come into right position. In opposite way, if by mistake our robot turns to left, our right sensor will start showing black value. The left sensor will continue to show white value, and in that case, we should turn right. So whichever sensor shows black color, we need to turn that side. If the left sensor is showing black color, we need to turn to the left. If the right sensor is showing black color, we need to turn to the right. And the fourth condition is we come to the end of the road and we see black end. So the both sensors show black, then we should stop. That is what we need to start coding. So let's go to coding the thin line variant of line follower. So we have our Arduino IDE and we need to read, store, compare, act. So we need to read. Now how many sensors I'm going to read? I'm going to read 2 sensors. If I want to read 2 sensors, I need 2 variables to store that value. So let me create those 2 variables first. The values which I'm expecting is 1 or 0, which means they are integer values. So I need to have integer variables. So I've created 2 variables, ls and rs, ls for left sensor value, rs for right sensor value. When we are creating 2 same type of variables, for example, in this case, ls and rs are both integers. In that case, I can use comma separated values. So int ls comma rs. Together I am defining these 2 variables. Now we need to read the values. And for reading the values, I have attached my sensors to CurioFire boards sensor/servo1 and sensor/servo2. For sensor/servo1, we use pin number A0 and sensor/servo2, we use pin A1. So we need to first write the mode of this pin. So pin mode of A0 is input because a sensor is attached. So we have set the pin modes, and now we will read the values. For reading the values, since the values which we are reading are digital, we will use digital read command, and we will have to store that value into our variables. That means ls equal to digital read A0. So I'm considering that my left sensor is attached to pin A0, which is the sensor slash servo 1 of Curio Fireboard. And we'll read the pin A1 and store it into RS. So we have done read and store, and now it's time to compare. For compare, we know we use if. And what is my condition? My condition is if both these sensors are reading white, I should go forward, and white is 0. So ls equal to 0. Why equal to? Because single equal to means assignment, while equal to 2 times equal to means comparison, and in the condition we are comparing the value. And so I'm going to AND this. Both conditions have to be satisfied for my overall condition. So both are 0. In that case, my vehicle should go forward. I want to write vehicle forward, so I'm going to use library for that. So let me go to sketch, add library. So I'm going to add Curio Fire Motor library, and I am going to create instance for that called as V. And so when I use the command here, it will be v.forward. We will go a little slow because we need to turn, we need to sense, we need to give time for our sensors to sense, and that's why we are going a little slow. The next condition is about turning. So I'll copy this if. Now if left sensor is 1, that means left sensor is reading black color. That means we have turned right by mistake and we need to turn back, which means we have to turn left side. So we are going to use hard left turn. If left sensor is showing black color, we will turn left. If right sensor is showing black color, we will turn right. So left sensor showing white, but right sensor showing black. Then we will turn right. I'll use hard right turn. And if both are black, that means I need to stop. So if left sensor is black, right sensor black, both black, then we need to stop. And for that we use command vstop. Let's recheck our program. We have included the library because we are using the Curio Fire Motor library commands. We have created instance V. Then we have also got two variables. We have declared two variables, integer type variables ls and rs, to store the left sensor value and right sensor value. We set the pin modes of A0 and A1. We don't need to set the pin modes of the pins of motor because that is taken care by our library. Then we read the value and we store the value. So we have done these first two steps, read, store. And then we are comparing and acting. There are 4 actions, so 4 comparisons we are doing. Both are 0, the sensor values means both are reading white, and that time we go forward. If left sensor is reading black and right sensor is reading white, we need to turn to left. Exactly opposite of that, if left sensor is showing white and right sensor black, we should turn right. and both sensors reading black, then we should stop. Let's compile our code. I'll save it later. Compiling is done. That means our code is syntactically correct, and we can upload the code and check whether it works properly. In our next video, we will write the code for the thick line follower.